Section 2.2 introduces graphing for the first time in our course, along with intercepts and symmetry. So let's make sure we understand what the graph of an equation represents. Well, the graph of an equation represents the collection of all points that satisfy that equation. That means that in example one, I'm struggling with the marker cap again. In example one, we want to determine which of the given points are on the graph of the equation. So the equation they've given us is y equals x to the fourth minus the square root of x. So again, if I were to graph this equation, I would end up with all the points that satisfy this in terms of both x and y. So the first point they give us is the point 0, 0. Well, if this point is on this graph, then this x and this y coordinate will satisfy this. So all we're going to do is replace each of the x's with a 0 and replace the y with 0 and see if it's true. So 0 in for the y. And is that equal to 0 to the fourth minus the square root of 0? Well, this is true because we're going to get 0 equal to 0. So the answer to the question is yes. Yes, 0, 0 is on the graph. Not a very exciting example because everything was 0. So part B on that problem says, what about the point 1, 1? So now we're going to replace again x with a 1 and y with a 1. So we'll have 1 is equal to 1 raised to the fourth power minus the square root of 1. Well, this is 1 on this side. 1 to the fourth power is 1. Square root of 1 is 1. 1 minus 1 is going to give me 0. So because these are not equal, this point is not on that graph. So no. Point 1, 1 is not on the graph. Now, in general, you're not going to sit here and play guessing game with every point underneath the sun. Right? That would be an infinite number of points. That would not work. What about the last one on that example? So this is part C. Part C says, okay, what about the point 2, 4? So again, here's my x, here's my y. So is 4 equal to 2 to the fourth power minus the square root of 2? Well, 2 to the fourth power is 16. The square root of 2 is around 2.1. And 16 minus 2 something is not going to be equal to 4. So I don't even need to go any further. It is not. So when you start graphing, one of the most useful pieces of information you can have are the intercepts. So what are the intercepts? Well, the intercepts, by definition, intercepts, that was really sleepy, are the places, now let's do points. Here are the points where the graph crosses, and I'm going to put in here or touches the axes. So we'll have x-intercepts and we'll also have y-intercepts, and it's a place where the graph is either going to cross those axes or it might touch those axes. What do I mean by touching the axis? Well, you might have something that does something like this. In which case it's touching the axis right there, that x-intercept, but it's not crossing it. So remember that intercepts are wherever we touch an axis. We don't have to cross it. So let's work on some directions on how to find intercepts so that you have those. So example 2 asks us to find the intercepts and then graph by plotting points. So part A is the equation y equals 3x minus 9. Now you should recognize this as a linear relationship because there are no exponents, no radicals, no x in the denominator. This is a line. It's somewhat in the form, so we're going to think in the back of our line, y equals mx plus b, and this is linear. So this is a line. How does it help me? Well, it tells me how many points I'm going to need to be able to plot it. The directions are specifically asking us to find the intercepts, though. So let's come in and find the x-intercept. If I'm going to find the x-intercept, the y-coordinate is 0 because that's where we're crossing the x-axis. So the y-coordinate is 0. So what we'll do is we're going to replace y with 0 and solve. I'm going to put 0 in for y and go solve for x. So we'll get 9 is equal to 3x, or x is equal to 3. So we now have an x-intercept, and our x-intercept is at the point It is a point, so make sure you're writing it as a point. 3, 0. Find the y-intercept, we're going to do the same thing, but kind of the opposite letter. So to find the y-intercept, this is where we cross the y-axis. We're going to replace x with 0. And so on. So in our equation, y is going to be equal to 3 times the 0 for x minus 9. So we see that the y-intercept is at -9. In case you didn't catch, INT is what I'll use to abbreviate intercept. So we have 0, -9. And because it is a line, those 2 points define that line, and that's all we need. So to graph it, we just need to graph those 2 points. So on the x-axis, we're at 3, 0. And on the y-axis at -9. 5, 6, 7. There is our line. That's our first graph. Yay! Okay, let's do something that is not a line. So part B on example 2. Our equation this time is 4x squared plus y equal to 4. This is a non-linear relationship. And how do I know that? Because I see an exponent of 2. So because of the exponent, this is not a line, which means I need more than 2 points to be able to graph it. But we're going to start off the same place. Let's go find those intercepts because they're the friendliest thing to find, and it gives us a nice idea of what's going on. So to find the x-intercepts, again, you're going to replace y with 0. So 4x squared plus 0 is equal to 4. That's just 4x squared equals to 4. So x squared equals 1, and x is equal to plus or minus 1. So we now have 2 x-intercepts. So we know that as x-intercepts, let me write them over here. We have 1, 0. We also have -1, 0. So right now, we start graphing. We have a point over here, and we have a point here. Let's go find our y-intercept. So to find the y-intercept, you replace x with 0. So we have 4 times 0 squared plus y is equal to 4. That's just going to give you 1, which gives me the point 0, 4. So that. Now, if you want, you can plot a couple more points. And to do that, we can build a really quick XY table. If you have enough experience, you can tell me already what shape this is going to be. But if you don't, then you're going to build a couple more points. So we'll do a real quick XY table. Let's plug in a +2 and a -2. In other words, we've already got x values at -1, 0, and 1. So let's go further out and use +2 and -2. So that would be 4 times 2 squared plus y is equal to 4. You know what? To make this easier on ourselves, why don't we rearrange this? So we can see that y is equal to 4 minus 4x squared. Let me do it that way because that's a little friendlier than solving it each time. That's why we worked on solving equations at the beginning of the course. So when I do that, I'll have 4 minus 4 times 2 squared. 2 squared is 4 times 4 is 16. So this is 4 minus 16, which is going to give you a -12. So that's way down there. So at +2, we are way down here at -12. So now I can definitely see what that side of the graph is doing. When we plug in a -2, we'll get the same exact thing. -2 squared is a +4 times that -4 is still a -16. I'm going to get -12 again. So over here at -2, we're down here at -12. So our picture is something like that. And there is our graph. And if you didn't know, this is called a parabola. It's like parabola. And I knew that because I had one squared, one variable squared. If both variables are squared, it's a circle, which we'll do in a couple of sections. But for right now, if you have just an x squared or a y squared, you get this U shape out of it. The interesting thing about this U shape, which leads into our next discussion, is the fact that it has some symmetry. It folds across the y axis. And that's when we'll start with our next segment.